Hello everyone and welcome to another video. My name is Nick and today we are looking at intermolecular forces in chemistry, and we are going to look specifically at dipole-induced dipole forces. It's a little bit of a mouthful, but let's look at what this entails. So it involves a polar molecule and a non-polar molecule. So this white is our non-polar molecule, and this is our polar molecule. So the polar molecule already has a positive and a negative end, whereas a non-polar molecule does not. However, we do know that we've got electrons flowing around this non-polar molecule. So what happens is the electrons get attracted to the positive end of the polar molecule because opposites attract. And so they then move towards here and we get a temporary pole. So we get a induced dipole. So the name, if we think about the name dipole-induced dipole, so it's induced by a dipole. So it's a dipole-induced dipole. So this dipole induces a dipole. And so we get this side becoming negative, and then obviously the other side becomes a positive pole. And so we get now a force between these two poles. And this we call our dipole-induced dipole force. It's not as strong as a dipole-dipole because a dipole-dipole already had two permanent poles, whereas this is just temporary. The non-polar molecule doesn't have that permanent pole. So we've been going through in the previous videos, the ion-dipole force as well, which was even stronger because you had the positive ion and the negative side of the non-polar molecule. And so as we're going along, these forces are getting weaker and weaker. And now we have the second to weakest one, which is a dipole-induced dipole, where we've got a non-polar molecule having a pole being induced by this other polar molecule. So let's look at how that might happen. So we've got, say, water. And let's say we've got oxygen inside the water. So this is oxygenated. And you've got these O2 molecules. And so what you'll have is the negative end of the water molecule attracting the electrons to this side. Sorry, the repelling. So these would then repel the electrons. And so this would then become positive. And so you'd have the electrons here. And so there's this weak force between your positive end of the molecules. And so this is now temporarily positive. And so this is not a very strong force. If we think of the water is much more strongly bonded to its own molecules because of the dipole than the oxygenated water. So we see that these bonds eventually break and the water rises, and if you were to mix oxygen into the water, it gradually rises to the surface. Think about carbon dioxide as well. That also, the gas then comes to the surface. The water is not strong enough to hold those bonds in. And so let's have a look here. This is now the positive side. And so that's going to attract electrons. And so we have this temporary pole here. And so these are our weak. So these are weak. These are weak forces. Now, in the next video, we're going to look at the weakest of all of the intermolecular forces, the world champion weakest force coming up, and it's to do with London. So, look forward to seeing you in the next video. If you found this interesting, it helped at all, please find the subscribe button and you will get notifications on more videos. Share as well and like and all that good stuff. And I'll see you in the next video. Have a great day.